All right, today we're going to be looking at compound interest, and our goals are to calculate compound interest and also present values. So in the last lesson we looked at simple interest, which was interest that was just calculated based on the principal alone. Today we're looking at compound interest. This is interest that is computed on the original principal as well as any accumulated interest. So you're essentially earning interest upon your interest when it compounds, maybe monthly, daily, quarterly, etc. So this is our new formula. Again, you may want to jot this one down. I do believe on the formula sheet that I give you, I will add in parentheses around the n and the t here. Which I did put a formula sheet with the quiz. But A, of course, is our future value, as we've been looking at. P stands for our principal. R is still our rate as a decimal. But the new variable you're going to be seeing is this n variable. This is the number of times the interest compounds per year. And then T is still the number of years that we are investing our money. So the n variable will be told to us using words in the given problem. So if it says that we are compounding it annually, that means that it is being compounded one time. So n would be 1. Semi-annually means 2. Quarterly, n equals 4. 4 times a year. Monthly, there's 12 months, so n would be 12. And daily, n will be 365. I think in the homework it may say to use 360 instead of 365. You can if you want, but on the mini quiz you will use 365 for daily, so if you want to do that. So our first problem, example 1. You deposit $2,000 into a savings account. That is my P at Hometown Bank. The interest rate is 6%. Remember that for 6%, we need to change that to a decimal, which is 0.06, not 0.6. That would be 60. And then they also tell us that the interest is compounded annually, which means that n is 1. How much money will we have after 3 years? T will then be 3. So we have the same formula that we just went over in the last example, and we're going to plug our values straight in there. P is 2,000. 1 plus R is 0.06 divided by n, which is 1, and raised to the nt power. Again, this is like the 1 times 3 power. So sometimes the hardest part of these lessons is putting it in our calculator correctly. So let's see if I can fit both of these on my screen. Alright, so we'll type in 2,000. Parentheses 1 plus 0.06 divided by 1, close your parentheses. Now when you do your caret, if you have your graphing calculator with you, you guys have the newer ones which puts the little exponent up there, you can just type 1 times 3. If you don't have the newer calculator or you're using an online calculator, you'll want to add parentheses 1 times 3 and then hit enter. We're always going to round to the nearest hundredths place because this is money that we're looking at. And so we do get $2,382.03. Part B says to find the interest. Now, we are not using I equals PRT because that's for simple interest, and this clearly says compound. So to find the interest, we actually take the A value we just found, and we subtract the P value that we had in the original problem. So the A value we just found was 2,382.03. We're going to subtract 2,000, which was the principal that we had back up in the original question. And then that tells us we earned $382.03 in interest. Next one, similar problem. We deposit $7,500 into a savings account at PNC. That would be our P, our present money that we're putting in. Interest rate, same as the last one, 6%. I will tell you that the interest rate at PNC is not that high. It's usually much lower. But change it to a decimal, 0.06. And this time they tell us that the interest is compounded monthly. Remember, this tells us our n value, and we know there are 12 months in a year, so n will be 12. How much money should we expect to have after 5 years? So that would be t equals 5. And we plug that straight into our formula. Again, if you're using an older calculator or maybe your online calculator, add parentheses around that, which on the formula sheet I did for you. And you can do it piece by piece, or you can just type it all in. Be sure to close your parenthesis before you put your caret button. And then in my exponent, I should have 12 times 5. Again, I don't really need these parentheses because I have the newer calculator, but I'm just showing them in case you have the older calculator. And actually, let me show you what the older calculator would look like. You guys can do that. So if you have the older calculator, it would look like this. When you do your caret, oh no, this one still is showing it. So we should get $10,116.38. Again, to find our interest, do not use I equals PRT anymore. We're going to take the future value minus the initial deposited value. So that's $10,116.38 minus our $7,500 that we put in. And we should find that we earned $2,616.38 in interest from just leaving our money sit in that account. All right, example 3 has us comparing rates. So it says you're borrowing $8,000 for a car and have a few options to pay. Now, in this instance, it's different than the last two. The last two, we were depositing money into a savings account, both of them, which means you want to earn a lot of interest because you're saving the money. In example 3, this says you're borrowing money and then you're paying it back to the bank. So you actually want to pick whichever option gets us the lower price because we are borrowing the money. If we were investing the money and we were saving it up for something, we would want to pick the higher of the two. So for both of these, we're using the same formula we had on the front. The first one, interest rates are the same, 10%, so R will be 0.1. Not 0.01, that would be 1%. And time is 3 for both of them. And P is 8,000 for both. But the N value changes. We have daily versus monthly. So our N is 365 for daily versus 12 for monthly. So we'll plug that straight in. P times 1 plus R divided by N to the NT power. So we should get $10,798.43. Now for that second problem, the only thing that I have to change is the 365 to be 12. So remember on your graphing calculator, there's a shortcut. You can press second, enter, and it'll recall what you typed last time. You can just go change that 365 to a 12 and delete one of the numbers. Change that 365 to a 12. And delete one of the numbers. So we should get 10,785.45. So again, because we are going to have to pay this back for borrowing the $8,000, we want to pick the smaller amount because we want to pay the least amount for the car. So our best option would be monthly. The more times it's compounded, the more interest that you're paying or earning, depending on the situation. All right, our last one is continuous compounding. This occurs when the compounding periods increase infinitely. So it's not just being compounded every day. If it's being compounded continuously, it's being compounded every second of every day. So it's the most frequently it can occur. I always say, a little saying, whenever you see compounded continuously, use the formula that has the E in it. Okay. So this is called the PERT formula. Some of you that took pre-calc may have learned this already. P still stands for our principal. E is actually a constant. This is Euler's or Euler's number, depending on how you pronounce it. It's kind of like pi in the fact that it's an irrational number that goes on forever. It is actually a button on our calculator. So to get the E button, you either press the second and the division sign, which will get us E. And if you hit enter, you'll see there's the number. You also can press second and the ln button, which is right down here on the left. That'll get you e to the whatever power. This one is more useful because our formula does have exponents of r and t. Remember that r stands for our rate as a decimal, and t is still our time in years. So for part A, we borrow $10,000, that's our P value. T is 7. R is 0.08. This one asks us to find the balance if it's compounded continuously. So again, continuously tells us that we're using the formula that has the E in it. P times e to the RT power. So we will have 10,000 times e to the 0.08 times 7 power. Those backwards. So again, in our calculators, type in 10,000. And then times the E button again, I would press second ln because it automatically gets you that exponent. And in the exponent, we're going to put 0.08, which is our rate, times 7 years, which is our time. And so we should get 17,506.73. Part B says the same scenario, P is 10,000, T is 7, R is 0.08, but this time it's being compounded semi-annually. Semi-annually tells us that our N value is 2. So in this case, I'm using the old formula, which is our P times 1 plus R divided by N to the NT power. So 10,000 times 1 plus 0.08 divided by 2 to the 2 times 7 power. And I should get 17,316.76. So you can see that the compounding continuously gets us a higher amount of interest. Again, the more times you calculate the interest, the higher the interest will be. All right, time for you guys to try the closure. Go ahead and pause the video and see if you can try those on your own. Whenever you're done with them, click play and I will go over the answers for you. So for example A, we should have used our PERT formula because it says continuously. P times e to the RT power and get 7,166.65. In part B, it says compounding quarterly, which is n equals 4. So we should have used our other formula, P times 1 plus R divided by N to the NT power, getting us 7,143.74.